Hey, my name is Tim, and I'm going to be presenting my group's final project for Geography 525 at the University of New Mexico. Our project was studying the infodemic, identifying fake news using machine learning. For a little bit of background, the spread of fake news has been widespread for about 10 years now and has caught popularity since about 2016. Currently, it's spreading much faster than moderators can manually moderate and flag the news, so we believe that an automated flagging and filtering method is required, especially for things like social media posts or search engine results. For this study, we used a data set that we found on Kaggle consisting of almost 45,000 records. Each record contained the title, text, date, subject, and category for a news story, the category being real or fake. In this data set, it was almost 50-50 split, i.e. it was balanced, but in this case it was 48% real and 52% fake, which meant we had 2,000 excess fake news stories that we had to drop to make the data set balanced. We tested 5 different models and their applicability for this project: a Gaussian naive Bayes, a multinomial naive Bayes, KNN, a decision tree, and a random forest. For the KNN algorithm, obviously fake and real news, that's a K cluster of 2, and we used the brute force algorithm because it performed the best. Before we could do any of the machine learning, we needed to process the articles themselves. So we did some standard natural language processing. We removed stop words. These are common words that provide syntax but not meaning, like it, the, a, etc. We lemmatized the words, which means getting to the root form of a word. Like this could be converting walking and walked to walk. All the real news stories contained the word Reuters, so we dropped Reuters. And then we applied something called a TF-IDF algorithm, which basically converts the keywords from the articles into numbers that the machine learning algorithms can understand. Ultimately, we ended up with 184 different words and, like I said before, about 40,000 records. Those are news stories. So each news story was reduced down to scores across 184 different keywords. Some of the models required hyperparameters to be tuned to make their performance as best it could be. This is called optimizing those hyperparameters. Here you can see a plot or a box of the hyperparameters that we tested, and in red are the ones that we found using a grid search to be the optimal parameters. You can refer back to this if you want details on how each of the models was designed. So we tested the data after doing a 75-25% train test split. So this is the results from being tested on that test data set that the models had never seen before. The most important 3 plots here are on the right. That's the fake news F1 score, the real news F1 score, and the total accuracy score. As you can see, the random forest model performed the best by far on all 3 metrics. The multinomial naive Bayes outperformed the Gaussian, which we expected because the distribution of word frequencies is not Gaussian. Interestingly, the multinomial naive Bayes outperformed the decision tree, and the KNN algorithm was the worst by far. We also tested the processing time, and we found that the KNN was by far the slowest, while the multinomial naive Bayes was by far the fastest. We looked at some of the important words that the models were using to make their determinations about what news stories were real or fake. This is the results from the random forest. You can see that said is the most important word by far. So we looked at the distribution of the TF-IDF values of said to see if there really was a difference between the fake news and the real news. Important to note here, the distribution is not Gaussian, as I said before, which is why the Gaussian naive Bayes performed so poorly. You can see that in the fake news stories, the frequency of low TF-IDF values was very high, but also high values was much higher in fake news, while the real values dominated in this middle portion. So there is definitely a difference between fake news and real news in terms of their usage of the word said. To conclude, we found good performance all around. You can refer to that multicolored bar plot earlier for all the statistics. We found that the random forest was the best for accuracy, about 93% accuracy and F1 score. The multinomial naive Bayes was much faster. It was 56 times faster than the random forest, which meant it could process a whopping 68,000 articles per second. This is ideal for high pass-through applications like flagging news stories that get reposted quickly on social media, or when you have search results from a search engine that returns many thousands every second. For this, you sacrifice 3% accuracy, but it's 56 times faster, so that's a good trade-off if your primary concern is the speed. We found that the random forest and the decision tree were the best for interpreting or for people interested in the linguistics, because you can look at the decision trees and parse exactly what the model is considering at every step when it's deciding whether a news story is real or fake. The KNN performed really poorly, and we think that is likely due to the cursive dimensionality, which is a artifact in KNNs where they scale extremely poorly to high dimensional data. In this application, we had 185 total features, one of those being the labels, so 184 different variables that were being considered. We think this is the primary cause of the KNN's poor performance. There are some questions left for future research. There are some models that we didn't consider that are more complex, like a neural network or a self-organizing map. These models could be tested with the same data set and compared to our results. That would be an interesting comparison. And we'd also like to test our classifiers that have been fully trained on articles from outside the data set. These could be Reuters articles from an earlier period or more recent Reuters articles, but also news stories from other outlets or sources. We'd like to thank our professor for this project, Dr. Yang, for her help with the code and preparing all the documentation and manuscript, the Kaggle dataset that we used. All of our work relied on scikit-learn, so that was a huge help. And we used matplotlib to generate all our figures, so a big thanks to them.